Welcome to our EYM session on agricultural and biological engineering. So we're going to start out with meeting some of our faculty and ABE ambassadors. So I'm John Evans. I'm an assistant professor in the department. I teach our power and machinery management course, our advanced machinery technology for agricultural crop production class, as well as our capstone. So every student that comes through is going to take our capstone course, and I'm one of the three professors that teaches that. The majority of my research is focused on machine automation with an aspect of precision agriculture and certainly quite a bit of robotics.
Hi, my name is Reece Durbin, and I'm a junior in the Agricultural and Biological Engineering Department with a focus in agricultural engineering. Today I'd like to tell you a little bit about myself. First off, I'm from Thorntown, Indiana, a town just roughly in between Purdue and Indianapolis. My favorite ABE class was ABE 305. Titled Physical Properties of Biological Materials, where we had the opportunity to study different properties of grain and food products and how we can most efficiently produce those to get them to the consumer. Some of my campus involvements are Farmhouse Fraternity, where I was the previous VP of Finance as well as Finance Chair, and am currently the Director of Alumni Relations. The Purdue Utility Project, which I'll touch on a little later, and then the American Society of Agricultural and Biological Engineers. Regarding my internship experience, I've completed an internship for Precision Planting, a precision agricultural company in Tremont, Illinois, where I was a research and development intern in their agronomy department. Secondly, I completed an internship for Grain Processing Corporation, otherwise known as GPC, in Washington, Indiana, where I was a division engineer intern in their corn wet mill. And also I had the opportunity last summer to travel to Eldoret, Kenya, where we studied abroad with the Purdue Utility Project team. This summer, I plan to intern for EYM, otherwise known as Archer Daniels Midland, one of the largest grain processing companies in the nation, as a milling engineer intern at a flour mill in Mendota, Illinois.
Hello, my name is Brandon Kitch, and I am from the Agricultural and Biological Engineering Department. I'm currently a junior studying agricultural engineering. I'm from Durbin, Indiana, and just to get into a little bit about myself in the agricultural engineering department, my favorite ABE class was ABE 325, where I was able to work with hydrology and soil water conservation. In this class, we worked a lot on irrigation systems for agricultural application and hydrology, so how water moves through urban and rural areas. Some of my campus involvements are Farmhouse Fraternity, where I currently serve as the Director of Administration, and I am formerly the Athletic Chair. I am also a member of the Purdue Foundation Student Board, which is an organization on campus that works with Purdue donors and the President's Council under the President of Purdue. And then I also serve as a ASP first-year engineering mentor, where I currently have a first-year engineering student who I help mentor through the process of picking their major and just classes in general. My internship and research experiences so far, I served in a mechanical rebuild shop back in my hometown of Durbin, Indiana for a summer, where I got to rebuild lots of mechanical parts and put them onto older tractors and agricultural equipment. And then last summer, I was fortunate enough to have a crop engineering internship with C&H Industrial. That's Case New Holland. They are the second largest agricultural equipment manufacturer in the United States, where I was able to work on the combine, which is pictured on the screen. So I did a lot of design work along with testing of parts and materials, and I got to travel out to Arizona to take that photo with the test engineering team. My future plans are to continue at C&H Industrial next summer, where I plan to work on straight frame tractors between 200 to 400 horsepower. And then after I graduate, I hope to work for an agricultural equipment company of any sort.
Hi folks, my name is Ankita Raturi, and I'm an assistant professor in the Department of Agricultural and Biological Engineering, where my research is really looking at the design of different kinds of digital technologies for resilient food and farming systems. And so you'll notice that I'm actually a software engineer by training that has now found a home in the ABE department. And this is a story that will ring familiar as you listen to lots of different folks who are actually working within our department. So I teach a couple of courses that are really focused around providing students in the College of Agriculture the experience with informatics, so things like software design, things like data science, and even sometimes starting to lay the foundation for folks to be able to pick up techniques in machine learning and artificial intelligence to really think about how to serve, right, not just agriculture, but food systems a writ whole. And so I'm really here to tell you a little bit more about some of the different things that we're doing within the department. But I want to start actually with a quick question. Take a moment and have a little think. What drives you to pursue engineering, right? What are the things that you really think about as you ask yourself the question, why do I want to be an engineer? What kind of engineering do I even want to do? What types of people do I want to work with as I come out of my career? So take a moment, right? A lot of our students will talk about things like wanting to be able to tinker, right? We love playing with different kinds of equipment, with machines. We like playing with code sometimes. A lot of our students talk about experimentation with systems, right? Sometimes you're designing really tiny systems. Sometimes you're engineering entire food systems, right? There's a lot to explore and experiment with in agricultural engineering. A lot of our students will also talk about this idea of service, right? Engineering is the design of useful things. I like being useful. And so I'm hoping that some of these things also ring true for you as you think a little bit about what kind of engineer you want to be as you pursue a career at Purdue University. So let's take a moment and think a bit about what agricultural engineering is. Oftentimes, people might think about just the agricultural side of things, so farm equipment. And it's true, right? Our history in agricultural engineering really comes from the design of off-road machinery. We have incredibly deep expertise in machine design and thermodynamics and fluid power, right? If you want to build big, complex machines, we're the place to do it in an outdoor environment where we're really thinking about that interaction between machines and environment and agriculture. Right? But we also think about the design of these really delicate things to help us understand the world around us. A lot of our faculty and even students do work looking at instrumentation and sensing, right? So proximal sensing, when you go right up close to a leaf to see what the actual, right, the composition of a leaf is. We do remote sensing, so thinking about the use of satellites, UAVs, and other types of machines at a distance to be able to collect data about the world around us. And right, we're really experimenting with techniques like computer vision to do tasks like phenotyping. A lot of our work also includes then things like automation and robotics, right? As the world around us is changing, as we're seeing digitization throughout the food system, it means we need agricultural robots. And so there's a lot of interest in being able to not just automate large equipment, but also design small, nimble robots, right? What would a farm look like if you had an entire fleet or a swarm of small robots doing planting? Right? There's a lot of potential for us to completely reimagine the way in which we design different kinds of pieces of equipment, including robots, for agriculture. More recently, and this is something where at least my heart often lies, is the design of software to be able to support different kinds of stakeholders throughout food and farming systems, right? And so that means that we need to be able to think about the design of software to help market managers coordinate food production in the local food system, all the way to thinking about, well, how do I actually support a large-scale commodity farmer be able to actually manage thousands of acres? That's a ton of data. And so in agriculture, we really have not just big machines and big data, we have interesting machines and complex data. And so there's a lot of potential for you to really build whatever kind of path it is you want, depending on the kind of engineer that you want to be. Right? So thinking about how to be useful, but also about how to integrate a lot of these different kinds of techniques and skills that are highly diverse. And so we're really interested in these like really grand challenges, right? These are not small questions that we ask in agricultural engineering. We ask questions around the design of technology to empower stakeholders, really to be able to improve downstream resilience of food systems and agriculture, right? And so we need to be able to help people adapt to climate change through this different kinds of smart food and ag tech. We really want to be able to bring power to the people, right? By thinking about automated data and machines, not as replacements for humans, but as support for humans. Really thinking about how to create resilient, connected communities and really harnessing informatics for different kinds of biological diversity and innovation, right? These are the grand challenges that we're really oriented towards in agricultural engineering. So we then start to think a little bit about how we might actually engineer solutions in this like very complex and interesting space, right? We have some people that are interested in really sensing and simulating the world. So not just can I look at a plant across these different levels from subsurface to extraterrestrial, but can I actually create digital twins, simulations of farms and food systems, right? We then start to think about the flows of information, food, energy, resources, water through these complex food systems, right? Many of us inadvertently end up being data scientists as we deal with lots of complex data coming from fields across the world. And ultimately, right, we're engineers, so we also want to build tools. And really, we're interested in tools for people, right? So diverse tools for diverse people, really reimagining what that farm field kit looks like. And there's, I suspect, a place for every type of engineer within this community of people oriented towards agriculture. So let's now spend some time hearing more about the ABE experience, and I'll hand it over to John.
All right, so we are the #1 ranked ag and biological engineering program in the nation. We've been #1 ranked for, I think, 11 out of the last 12 years, so we're very well regarded. We have an excellent job placement, over 99%. So if you come to our department, graduate, there's a really good chance you're going to leave here with a job. And we have a bunch of scholarship opportunities. So we award over $100,000 in scholarships to our students, and we're a pretty small department, so that doesn't get spread out super thin. So there's a good chance that if you join the department, you might get some of that money. So what makes us a top-ranked program? Well, I think the biggest thing is our individual interaction with the faculty. We have, like I said, small class sizes, 12-to-1 ratio of faculty to students. So you really get to know the faculty in our department. It's like a family. We have a lot of opportunities for student competitions, which I'll talk about later, as well as global experiences from both colleges, which is a unique opportunity. We have a very customizable path. So the way you get through our department, the classes you can take, you can really kind of choose your own adventure in that regard. We also offer a lot of internship opportunities and undergraduate research. So you can go out and internship, and we promote that and certainly encourage it with our students to go out and work for a company in the summer, figure out if that's what you want to do, and then come back, continue your education, and the next summer you can do something different, or you can come and work for us as an undergraduate researcher and see if that's a path you'd be interested in. And then certainly the hands-on aspect in the classes. And again, that's another big unique part of ag and biological engineering, is really believe on that hands-on learning aspect. So now we're going to talk a little bit about our courses that you'll take in ag and biological engineering. So I won't go through all of these, but this is kind of the core coursework that you'll go through. You'll see it's very similar to some other departments. We have your core, thermo, design of electronic systems, the fluids, all through that. So very, engineering-based core, as you can see there, which translates into, after you graduate, you can do a lot with an ag engineering degree. Because we're so similar to a lot of other degrees, we're very broad in what you can go out and do in the world. So next we'll talk a little bit about our ABE clubs and competitions. So we have a lot of unique opportunities within the department in terms of clubs and competitions. AgriBot, this is a competition around creating an autonomous robot to go and actually weed a field autonomously. So this has been a competition for a few years, and students get to actually go and get hands-on in this autonomy space, which is a really great opportunity. There's quarter scale, which I'm the advisor for. So this is the quarter scale tractor competition. It is a international competition where students actually design and build a quarter scale pulling tractor every year from scratch. So you get a real opportunity to take what you've done in the design classes and other classes and apply that to a machine. You'll design it from the ground up, and then you'll actually go and build the thing. And then you'll take it to a competition that we have. Usually we compete against 26 other teams or somewhere in there to see how your design stacks up. So that's a great competition. We also have soybean competition, which is more materials based, so trying to figure out how we can use soybeans to create different materials or products. There's the pup competition, which I think you heard a little bit more about earlier. And then we have our digital agricultural club. We actually go get hands-on experience with digital agriculture, sensing, data acquisition, and data processing. So all great opportunities, and you're free to join these, or we encourage you to join these, 1, 2, 3, all of them. It's up to you. Next, we're going to talk about the most common industry sectors that our graduates go to. The first is going to be automotive. So design and testing of vehicle systems. This could be for a company like Ford, Toyota, or one of our big ag manufacturers like John Deere or Case IH. Consumer goods and electronics is another one where our students end up. Anything anywhere from design and testing of products like lawnmowers, tools, anything like that. We put students there. Engineering services and consulting, so going to work for a consulting firm that's going to provide design engineering and mechanical consulting for other companies. And then maybe some more that you wouldn't think about could be the food and beverage sector. So we actually place a lot of students in this sector. This could be designing equipment for processing in these giant factories. Another one is manufacturing and machinery. So again, looking at making these machines and manufacturing processes. And then the last one I'll talk about is renewables environmental. So this has become a very popular sector, as you can imagine. And so this is actually thinking about precision agriculture. How can we actually produce more crop sustainably as we go forward? So again, those are just some of the potential places you'll end up. And once you get to those places, these are kind of some of the jobs you could do within those subsets. So there's things like design engineers. So actually, doing the CAD work, designing components. There's production engineers, facility design. So actually designing the buildings where these things are taking place. Safety engineers, among many others. There's a lot of. That's the great thing about engineering. There's a lot of diversity in terms of once you have this degree, what you can be doing in your day to day. And certainly that's another great place where internships can help you understand what each of these actually do. And they, again, on potential companies. So this is a list of companies that we've taken from our alumni survey. So over the last 10 years, I believe, this is where our students have ended up. So you can see the diversity there in terms of placement. We have our traditional, ag machinery companies like John Deere and C&H. But then there's a lot of other diversity with automotive. You see your Fords, your Hondas, your Toyotas. And then, as we mentioned, there's all kinds of others like Cummins. There are farm service companies like Grips, biological companies in the ag sector like Pivot Bio. So a large range of where you can go and work after you get out of school with an ag and biological engineering degree.
Awesome. So now that we've heard a lot about our program, let's hear a little bit more from our ambassadors directly. I'd love for you guys to actually start by maybe telling us a little bit about your story. How did you end up in agriculture and engineering? Do you want to start, Brandon?
Yeah, so I grew up in a small rural community, so I always had a passion for agriculture. But I always had like a development process that brought me into math and science and engineering. Mm-hmm. So I knew that I wanted to go into engineering. I just didn't know if agriculture was the right fit for me. So I actually ended up talking to a couple alumni who worked for companies not in the agricultural field because I was really worried, like, I love agriculture and I'll always promote that, but I didn't know if that's a field that I'll always end up in. Mm-hmm. So I was kind of worried about the applications of agricultural engineering and if I would end up in that field. So he really helped me decide because he works for Cummins doing finite element analysis on their engine heads. So he does material testing and computer simulation. Mm-hmm. That's something that an agricultural engineering degree can do, but you don't think that they can do. So that kind of solidified my thoughts of, I think agricultural engineering is a really diverse field, and it's something that I would really enjoy, and it's something that I could have a career in.
Cool. So it helped you build a path that was broad but still connected to your interests in agriculture.
Yes.
Cool. What about you? How's your journey, Reece?
Yeah, thanks for asking, Ankita. So I didn't grow up on a farm, but I grew up in a small town and worked for a lot of local farmers since I was 12. So I really gained a passion for the agricultural industry. And then with Purdue being so close and such a good engineering school, I knew I wanted to go engineering, but I didn't actually really know much at all about the ag engineering department coming in.
Yeah.
So I did work in the grain side of things before I came to college. I worked for a grain bin manufacturing company, but had no idea where that might lead. But long story short, I chose ag engineering over mechanical engineering due to the small class sizes, due to the family atmosphere type of environment. And after, as mentioned before, after I completed my internship with precision planting, which is what I thought I wanted to do in the precision ag, I realized there's an opportunity on the grain processing side. And so having had some experience there and then that background working for a couple local farmers when I was younger, realized that's what I want to do, kind of oversee the process work with the operators, work with management, and just kind of the day-to-day is always different, and I really enjoyed that and enjoyed seeing the end product.
Yeah, cool. I love that every time I hear student stories, I hear stories that include, yes, a diversity of disciplines and skills and a connection to agriculture, but I also hear this like unexpected delight that you find in ag engineering. It's like we didn't realize that we were going to find a home in this department, but we found this common space, and I hear that in your stories. Once you got here, were there things that continue to surprise you or unique experiences that you had that kind of helped solidify that decision?
So obviously coming out of the FYE process, it's a pretty general process, but once you get into the agricultural engineering department, it really feels like a home. Small class sizes, your professors really care about you. You can always go talk to them at office hours, and they're not like a 700 person class that you might find in a larger engineering department. They really care. They're really there to teach you. They'll work with you. They'll help you out in your classes. So that's been a really unique experience for me.
I'm so glad to hear that. Yeah. What about you?
Yeah, similar to Brandon, just the personal experience, and you feel like you can always go ask your professors a question, and you feel like they care about you learning and your success. And also the career opportunities, the internship and research opportunities, I would say, is another huge area that really made the decision easy for me.
Yeah. I know that you were also involved in PUP. Would you mind sharing a little bit more about what your experience was like doing a study abroad as well?
Yes,
Yeah.
yes.
Yeah.
So the PUP team, which stands for Purdue Utility Project, is it was nearly like a mission trip in my eyes, and we had the opportunity to go to Eldoret, Kenya, and help a center down there where students could come in and learn traits such as welding, things that I was kind of interested in, and so we got to almost turn around and teach them how to maintain their vehicles better. And those utility vehicles, they use those for a variety of different purposes. So we spent 2 weeks there getting to learn more about them, first and foremost, but then also getting to help teach them and learn from them throughout the process.
I really appreciate that, yeah. What about you? I think, you've talked a little bit about some of your extracurriculars. Can you tell me a little bit more about your experience with life as an engineer?
Yeah, so life as an engineer, I mean, obviously, you're doing a lot of math, you're doing a lot of science. It's not easy work, but I really feel that the agricultural engineering department helps me pursue other opportunities, such as Purdue Foundation Student Board, where I was able to go with the president of Purdue to his Boilermaker Ball and meet people like Gene Cady, Matt Painter. There's a bunch of astronauts that come there, but that all comes back to my studies, right? I'm not locked in a classroom all the time because of the opportunities that agricultural engineering provides. It's not all homework based. It's not all like you got to do this and there's things to do every single day like you might find in other departments, and some of my friends experience that. You do things in lab that are actually practical, and then you can take some of that experience home. You do your homework, but then you can also have time to explore other opportunities around campus, which in my experience, I haven't seen that a lot in some of the other engineering disciplines.
Yeah.
So I'm really happy with my experience here.
Awesome. So you're able to find space, it sounds like, to connect with other people, other activities, and really kind of like find your niche as you sort of explore in the world as an agricultural engineer.
Yes.
So I'll maybe just close with one last question. I want you to think a little bit about your future. I know that you will both graduate in a year or so. And so as you're visioning what your future looks like as agricultural engineers, what are some of the things that you're looking forward to?
So I hope that I can get a job in design or test engineering with a large agricultural equipment manufacturer. And then currently I'm looking at some grad school options through Purdue and obviously through the agricultural engineering department.
Fair.
#1 grad school for ag and biological engineering. So I'm not sure which path I'm going to end up taking. Maybe I go into industry and then come back for that. But I'm always open to any opportunity that comes my way.
Awesome. Reece?
Yeah, for me, as mentioned earlier, I'll be interning at ADM. This is my last internship at a flour mill. So I hope to get a different experience there, but similar, and I hope to end up in the grain processing realm in some area. And so I think for me, getting to see actual projects be put in and implemented that I'm working on I know last summer I was able to see some of that, and that was really fulfilling. So being able to translate some of the classroom knowledge to the field is what I'm looking forward to most.
Awesome. Well, I thank you both for sharing some of your stories with us. And that's all we've got for you folks.